All right, this is your next section. It is 2-4, and it's writing linear equations. We said to write this equation of a line in slope-intercept form, we need two things. We need our slope, which was m, and our y-intercept, which was b. It says write an equation in slope-intercept form containing the points 5, -1, and 1, 1. So y equals mx plus b. So I need to know what slope is. Slope, you take x1, y1, x2, y2. The slope is 1 minus -1. 1 minus 5 is 2 over -4, -1/2. So slope is -1/2 x plus b. Well, we don't know what b is. We have to figure out what b is. All I have is an x and a y and an x and a y. If I can substitute this x and a y, I can figure out what b is. Why is this doing this? Okay, there we go. I apologize. Okay, so if I replace x, let's just go with the 1, 1. It's easy. If I replace y with 1 and I replace x with 1, and I get rid of the 1/2, so I get 1 plus 1/2 equals b, and b is 1.5. Then I know y equals -1/2 x plus 1.5 or 3/2. It's up to you. I don't care either one. Okay, so you had to find m, you had to find b, and then you had to rewrite your equation. Okay, write an equation in slope-intercept form from the line that has a slope of 3/4 and contains the point -12, 2. So once again, we put in the m, we don't know b, so we put in the x and the y to find b, and then write your equation. Pause if you need to. So we did a lot of work. We could just do a simpler method by plugging in a point and we're done. It says, did you know that we could use the formula for slope of a line to write the equation of a line? So this is an equation of a line, and then this is going to be an equation of a line. So if I take slope and I move this to the other side, and then I flip-flop sides, symmetric property, and remove the y2 and the x2 and just write x and y, then I have point slope form. Point slope form is a lot easier to use. It says write an equation in slope-intercept form for a line that has a slope of 4 and contains the point 4, 3. So I label what I have. I have an x and a y and I have a slope. I'm going to show you how much easier it is when you use point slope form. So anytime they want you to write a linear equation, you use this equation. Slope is 4, your x is 4, your y is 3, and that's point slope form, but they wanted it in slope intercept form. So we're going to distribute, and then we're going to bring 3 to the other side. Boom, we have our equation. We put in our point, we put in our slope, we're done. Here, you had to put in your point, put in your slope, find your y-intercept, and rewrite. This is a lot simpler. I recommend doing it this way. If you love doing it that way, you can do it that way, but this is easier. Let's try it again. Write an equation in slope-intercept form. So I'm gonna write my equation. Okay, you have x1, y1, so I'm gonna replace my x1, -1. I'm gonna replace my y1, 3. You could use the other point, and then they want you to replace m. So you have to do change of y over change of x, which is 1 minus 3, 3 minus -1. And if this is too fast, you can always pause and rewind. Or when I finish writing this, then you pause and copy it. Or just try it on your own. If they just wanted a linear equation, then you could just write this and be done. But they don't want just a linear equation. They want it in slope-intercept form. So we have to do this. And then when we solve, add 3 to both sides. So it's going to be positive 2.5. You can leave them as fractions or decimals. Nope, this should be, yep, should be 3 halves, I'm sorry. Okay, All right, flip. It says graph the following lines in the same viewing window. What do you notice? So if I were to graph this line, 1, 2, 3, 4, have a slope of 2, -5, 1, 2, 3, 4, 5, have a slope of 2. Let's just ignore that. What do you notice about those two lines? They're parallel. And what do you notice about their equations? They have the same slope. So parallel lines have the same slope. All right, graph the following lines in the viewing window. How are they related? Well, they're not going to be parallel, they're going to intersect. But there's something special about their intersection. So if they're not parallel, they intersect, but more specifically, they intersect at a 90-degree angle. They are perpendicular. So perpendicular lines do not have the same slope. They have opposite reciprocals for slopes. So if it was 3, the other one would be -1/3. If this was 2/3, this would be -3/4. So if one's negative, the other's positive, and vice versa. They want you to write an equation in slope-intercept form for a line containing -2, 7, and it's parallel to this graph. So if you want a parallel slope, you just write the same slope, and then you plug in your point, and you simplify. Pause for a second to write the equation. They want you to write the next equation in slope-intercept form, so you use your point-slope form. It contains the point 1, 4. And, well, you can't see the slope here, so you have to rearrange this equation into slope-intercept form first so you can see the slope. And then, if you want it to be perpendicular, you wouldn't use 2/3, you would have to use -3/2. So if they want you to write an equation, boom, use this formula, plug in your point, figure out what kind of slope you need. Then bring 4 to the other side. Okay, if this is too fast, pause, copy. The next one says the graph of this equation is perpendicular to the graph of this equation. The key word here is perpendicular. When you think of perpendicular, you need to think of your slopes. The slopes need to be opposite reciprocals. Well, we can't see the slopes. They're in standard form. You need to rearrange both into slope-intercept form. So here you see your slope is 3. Here you see your slope is -a/2. So if your slope is 3, you want the perpendicular slope to be -1/3. Therefore, you want -a/2 to be -1/3. Cross multiply to solve, you're going to get 2/3. On the back, there's a checking for understanding. I want you to complete it, pause the video, come back and check your work.